Hello, welcome to Supermicro's AI and HPC infrastructure update for SC24. This year, HPC is all about AI, liquid cooling, and some amazing innovations in CPU compute. When we were talking about AI, we were talking about three separate core product lines. Large-scale training with NVIDIA HGX, featuring 8 interconnected high-performance GPUs. The emergence of NVIDIA's MGX architecture with integrated ARM CPUs, high-bandwidth interconnected memory that are bringing AI inference and accelerated performance from the edge to the enterprise data center. The expansion of liquid cooling has been frankly unprecedented. Liquid cooling has gone from a niche HPC solution to the go-to solution to maximize performance of AI clusters within an overall power envelope. We have deployed over 2,000 liquid-cooled racks since June, which far exceeds most industry estimates for the entire year. Everything is about AI, but CPU computing innovation has continued. We are seeing accelerated CPU upgrade cycles. Impressively, we are seeing CPUs with over 200 cores, TDPs over 500 watts, but with significantly better performance per watt, and new memory with multi-rank DIMMs. Altogether, it amounts to a tipping point where the CPU installed base cannot afford not to refresh, with a potential 10x performance gains over previous generations. For the agenda today, our first topic covers how Supermicro is deploying the world's largest supercomputing clusters. So sit back and enjoy the rest of the show.
Although Supermicro takes pride in its system design, rack scale or data center scale is the key to delivering substantial leaps in computing necessary for HPC and AI leadership. Thanks to our strong partnership with NVIDIA, Supermicro is ready to integrate and deploy the NVIDIA B200 for large-scale liquid-cooled AI factories. With the TDPs reaching and even exceeding 1,000 watts, liquid cooling has nearly become a necessity. For example, the new GB200 NVL72 can reach up to 140 kilowatts per rack, and for dense compute solutions like this, air cooling isn't sufficient anymore. While there are many approaches to liquid cooling, Supermicro believes that direct-to-chip will be the dominant approach. Why? High performance and efficiency, fastest deployment, and easy maintenance. Supermicro designs its direct-to-chip liquid cooling solution in-house. Cold plates, coolant distribution units or CDUs, manifolds, and all the other crucial components of D2C are integrated as a rack-level solution, fully validated and tested at system, rack, and cluster levels from L10 to L12, providing a plug-and-play customer experience. While Supermicro's in-rack CDUs can handle up to 250 kilowatts per rack, Supermicro also offers in-row CDU option for scale-out clusters. Earlier this year, Supermicro made history by deploying the world's largest liquid-cooled AI supercomputer, consisting of our direct-to-chip liquid-cooled racks powered by our revolutionary Supermicro NVIDIA HGX servers. In one single cluster, we deployed 50,000 NVIDIA H100 GPUs and BlueField-3 SuperNICs, utilizing 6,250 nodes of our 4U 8-GPU liquid-cooled servers connected by NVIDIA's state-of-the-art Spectrum-X Ethernet, creating one uniform mega AI supercluster. Supermicro and NVIDIA are building AI factories at scale to deliver highly performant AI superclusters. These AI factories can be deployed to support various workloads: large training models spanning trillions of parameters, inference workloads, vertical-specific workloads, and multi-tenant AI clouds. Supermicro AI superclusters are completely validated with the two most advanced and powerful 400G networking platforms, NVIDIA Quantum InfiniBand and NVIDIA Spectrum-X Ethernet. In addition to our HGX superclusters, here's a sneak peek of our new rack-scale AI offering, the GB200 NVL72. Hosting up to 72 interconnected GPUs in one single rack. This is as dense as AI computation can get, thanks to the power of Supermicro direct-to-chip liquid cooling.
Now, let's talk about solutions that highlight Supermicro's commitment to innovation. Although AI and even HPC have increasingly leaned towards GPU-accelerated parallel computing, there are still HPC and scientific computing applications that require sequential operations at high precision. For demanding workloads that require both maximum high-performance compute and exceptional precision, we would like to introduce the FlexWI, which is purpose-built for HPC with Supermicro's multi-node system architecture. FlexWI is the pinnacle of compute density, featuring 4 dual-socket nodes with a total of 8 high-performance CPUs in a compact 2U form factor. Each node features liquid cooling technology to maximize efficiency and reduce instances of CPU thermal throttling. With our advanced liquid cool solution, we can capture up to 90% of the heat generated by the system. This allows FlexWI to maximize rack density. As an example, if you're using a standard 48U rack, you can accommodate up to 36,864 high-performance cores. Leveraging Supermicro's building block solution gives you the flexibility to include networking and storage components as needed. This multi-node architecture simplifies maintenance by providing front node access and I/O, facilitating convenient servicing from the cold aisle. FlexWI liquid cooling design, combined with Supermicro's innovative in-rack and in-row CDU solutions, deliver exceptional compute density for HPC workloads. The customizable architectures of FlexWI, combined with the efficient power and cooling distribution of Supermicro CDUs, enables you to create the ideal solution for your data center environment. As part of this multi-node family, you'll also find the Big Twin and Grand Twin multi-node systems, with dual socket or single socket respectively. These multi-node systems provide performance, energy efficiency, and scalability. Supermicro's resource-saving architecture features shared power and cooling for significant reduction in energy consumption. So to boost density and efficiency in cloud-native and virtualized infrastructure, the Big Twin and Grand Twin series are excellent choices. For a high-density blade-based approach, Supermicro's X14 SuperBlade series delivers high-density blade computing. With up to 20 blades per enclosure, you can pack incredible processing power into a minimal footprint. With both single and dual socket options available, you can have up to 40 Xeon 6 CPUs in an 8U blade enclosure. The SuperBlade architecture is highly customizable. It's all about being able to construct the most suitable rack-scale computing solution to meet the exact demands of your applications.
As far as adoption of AI is concerned, it's a new norm now. To be or not to be is not the question. Now it's about when and how soon we can deploy AI infrastructure. The debate is over and the race begins now. It's not just about speed, but about velocity, that is speed in the right direction. And that is where Supermicro shines, because Supermicro is moving with tremendous velocity in the field of accelerated computing. The TAM, that is the total addressable market, is exploding. More and more industry verticals are trying to capitalize on the capabilities of artificial intelligence. The good part is that to cater to this exploding demand for AI that the industry has never witnessed before, Supermicro is ready with the largest AI infrastructure portfolio in the industry with AI solutions from edge to cloud. Our AI infrastructure portfolio can be classified into 3 major categories. The first one, that is based on NVIDIA HGX platforms, that includes NVIDIA's latest and greatest accelerators ranging from H100, H200 to the B200. These platforms are designed for highest performance for trillion parameter plus large language model training, inferencing, and data analytics. The second category is based on PCI form factor accelerators. These platforms are designed for mainstream AI infrastructure, promising the best performance per dollar for multiple workloads, including visual computing, omniverse, and metaverse. Our third category is based on MGX platforms, mainly focusing on NVIDIA's great CPU and NVIDIA's latest and greatest accelerators, especially designed for modern AI workloads, including the GB200 NVL72, featuring 72 interconnected Blackwell GPUs. Before we go, I'd like to introduce a new high-performance solution for scale-out AI storage, Supermicro's JBOF, or just a bunch of flash. AI workloads are highly demanding for read, write, and high bandwidth that is critical to support a smooth data pipeline. Supermicro's JBOF utilizes NVIDIA's Bluefield 3 data center processing unit rather than the CPU memory NICs found in traditional storage servers. This approach delivers the highest storage performance and lower power consumption for an AI storage fabric.
At the heart of the next generation computing advancements is Supermicro's signature building block architecture, allowing a design process that ensures the highest level of optimization when adopting the latest chipsets, CPUs, or GPUs. This year, we're excited to deliver the new Supermicro X14 and H14 platforms, supporting Intel Xeon 6900 series and AMD EPYC 9005 series processors. These new CPUs deliver substantial performance gains in comparison to the previous generation. Supermicro's industry-leading thermally optimized systems are ready to fully support the highest TDP processors with air-cooled or liquid-cooled options. Supermicro systems raise performance metrics across the board for AI and HPC workloads, supporting up to 500 watts and 192 cores per processor. This allows for maximum compute densities of up to 36,000 CPU cores per rack. To ensure thermal stability when harnessing this new level of power, we've made enhancements within our FlexTwin, our Hypers, SuperBlades, and GPU-optimized systems. Let's take a look at one of our signature line of rack mount servers, the Hyper series. As far as general purpose data centers go, Hyper supports the highest performance CPUs, full-size PCIe expansion, and max memory slots with 12 channels and MRDIMM support. We've integrated direct-to-chip liquid cooling in our 1U Hyper, enabling dual 500-watt CPUs. For the air-cooled option, our 2U design is optimal to support dual 500 watts with our new vapor chamber heatsinks, providing superior performance compared to traditional heatsinks. Supermicro's X14 and H14 upgrades span across the entire portfolio with a variety of choices for better workload optimizations. We've improved thermals and mechanical airflow and reduced cable clutter across the board. These are just some of the platform enhancements featured in Supermicro X14 and H14, making them the ideal building blocks for your finely tuned AI or HPC clusters.
Thank you for watching our Supermicro AI and HPC infrastructure update at Supercomputing 2024. To learn more, please visit us at booth number 2531 or visit supermicro.com/HPC.